Screen ಕಾಣಿಸ್ತಿದೆಯಲ್ವಾ? Okay. The topics what we are going to discuss today is topics. First point, the definition of thermodynamics. Okay, it will be asked for sometime 2 marks. Next topic is second topic. You will be writing the applications of thermodynamics, where thermodynamics is exactly used, that you will write. Okay, with respect to engineering the applications and aeronautical. Okay. And third point is you'll understand what is macroscopic approach. Macroscopic approach and microscopic approach. So these are the 3 points. Okay, so including these 3 points, I will be discussing you with what is the definition of the system and surrounding. That is also an important topic, system and surrounding. Okay, so first what I do is I will explain you what is system. So based on system and surrounding, then I will come back to definition of the thermodynamics. So first one is system. System is nothing but it is a space. For example, the classroom is a system for a class teacher or a subject teacher. So classroom, it is one system. So this system, classroom, is a group of number of students. So number of students, assume that it is molecules. Okay, for example, one more. If you consider turbine is one system. This is turbine is a one system. So what is the definition of the system is, system is nothing but it is a group of matter or the space chosen for your study or research work. That is called as system. For example, I am a thermodynamics teacher. So for me, classroom of 3rd semester thermodynamics is a system. For example, in some engineers, they are working in the turbine department. So turbine is a system for them. Okay, any space, any group of matter which you have selected for the study, that is called as system. For example, here is a page. This particular portion you have consider as a research work. You are going to do some research work on this space. So this is nothing but system. Okay, have understood system? What is definition of system? Hello?
Yes, sir.
Yeah, fine. Any group of matter or the space or the reason is nothing but not REASON. This is not reason. The space REGION. Okay, any group of matter or the space or reason which you have selected, which you have chosen for your study. So that is for your research work. That particular mechanical component, that particular device, that particular machine, or that particular space, we will call it as system. Okay, so here if you are considering turbine as a system, then anything outside the turbine, we will call it as surrounding. Anything outside the system is called as surrounding. Understood? For example, if your classroom is a system, then another classroom, the neighboring classroom, is surrounding for you. For example, this is your classroom. One more classroom will be there here and left hand side, right hand side. Here, this will be the surrounding. Okay, this will be the system. That is a definition of surrounding. Surrounding is nothing but what? Anything outside the system is considered as surrounding. Okay, so this turbine is a system. Understood? What is the difference between system and surrounding? System is a group of matter which you have selected for your study, for your research work. And anything outside the system, we'll call it as surrounding. Okay, my dear students, I will draw one diagram now. You tell me which one. I will tell you the system. You mention me which one is surrounding. For example, Again, I will consider the turbine. This is a symbol which is used for representing the turbine. Here we are supplying steam. Okay, just an example. Okay, this is steam turbine. And steam will go outside. Okay, out. Steam in. And here I am attaching one generator. Okay. Now I am a mechanical engineer. I am interested in turbine. So I will consider this turbine is a system. Turbine is a system for me. And dear students, now you tell me which part, which component here it is surrounding.
Stream, sir.
Okay. What is G? You can think about what?
Stream surrounding.
Generator.
Stream is the surrounding.
Yes, generator is a surrounding. Steam is a working fluid. It is not considered as a surrounding. It is a working fluid. It is not a component. It is not a space. The pipe may be surrounding. The pipe which is you are using for supplying steam from boiler to the turbine, this pipe may be surrounding. But steam, you cannot say it is surrounding because steam is going inside the turbine. Okay, steam is not a surrounding. Steam is a working fluid. Generator is a surrounding. Very good. And here the turbine and generator are attached with the help of shaft. So this shaft you can call it as surrounding. So generator you can call it as surrounding. Okay, simple definition is system is nothing but it is a group of matter, a device, or it may be machine. It may be anything. There is some space that you are selected for your research, selected for your analysis. That is called as system. And anything outside the system is called as surrounding. Okay. The next is, now we'll come back to the definition of thermodynamics. Okay. So thermodynamics is a branch of science. I will explain first. I will be writing here. So thermodynamics is a branch of science, okay, which deals with study of energy conversions between system and surrounding. This is definition of a thermodynamic, simple definition of thermodynamics. There are many ways you can define the thermodynamics. Different textbooks will write the different definition of thermodynamics, but meaning will be remain same. Okay, what is thermodynamics? Thermodynamics is a branch of science, okay, which deals with study of energy conversions. These two words are important. Energy conversions. I will explain you what is this energy conversions. Energy conversions between system and surroundings. What is energy conversions is nothing but you can remember energy conversions nothing but energy transfer. Both are same. Energy transfer or energy interaction between system and surrounding. Okay, what is thermodynamics? Thermodynamics is a branch of science which deals with the study of energy conversions or energy transfer or energy interaction between the system and surroundings. So what I do is I will take the same example of turbine and I will explain you what is this, how energy conversions are there. Okay, I will explain you energy. I will give another example also. Do not worry. Okay, I will take the next page. Okay, so now you need to understand energy conversions. And after that, I will give one simple example how to remember energy conversion. For example, you consider one turbine. Why I'm taking always turbine is it is a best example to understand. So turbine, it may be water turbine, it may be steam turbine, or it may be gas turbine. Okay, here we are supplying some fluid. If it is water turbine, I will supply water. If it is steam turbine, I will supply steam. If it is gas turbine, I will be supplying gas. And here, my dear students, this turbine is connected to generator. Okay, this turbine is connected to generator. Is the screen visible for everybody?
Sir, yes, sir.
Yeah, thank you for your response. So this turbine I am considering as a system. Okay, this turbine I will consider as a system. Okay, anything outside the system is called surrounding. So this generator is a surrounding. This is system. Now, what is energy conversion is nothing but, for example, here it is steam, water or gas. This has high pressure and high temperature. The steam has high pressure and high temperature. So this is called as pressure energy. This is also one kind of energy, pressure energy. This pressure energy of the steam, when it hits the blades of the turbine, this pressure energy will be converted into mechanical energy or rotational energy. So here one form of energy, that is pressure energy, is converted into another form of energy. So that is thermodynamics. Energy conversion or energy transfer, energy interaction, or you can use the word one form of energy is converted to another form. Is converted into another form. So it may be any other form. Here I have taken pressure energy is converted into mechanical energy. Okay. You give me any examples of where energy conversions will be there? Any other example, mechanical engineering components?
Yes, sir.
For example, I will tell you, this is one more compressor. Okay. This is compressor. So compressor, we are supplying always mechanical energy. We will be supplying mechanical energy. And here I will be supplying air. So we will get energy outside. And dear students, here, what type of energy conversions are there? In this picture, in this diagram, this compressor converts mechanical energy into pressure energy. Because what is compressor? Compressor is a device which is used for increasing pressure of the air. Correct. Here I am supplying mechanical energy. This is one form of energy. We are supplying mechanical energy. This mechanical energy is converted into pressure energy. So one form of energy is converted into another form of energy. So that is thermodynamics. Okay. So similarly, for example, your fan. Okay, in your room, we have a fan. For fan, what type of energy you are supplying to the fan? Electrical energy. Very good. You are supplying electrical energy and you are getting mechanical energy. So one form of energy is converted into another form of energy. So here it is thermodynamics is involved. Understood? So anywhere, not only these three examples, anywhere where the energy conversion, that is one form of energy is converted into another form. So that is as thermodynamics. So what is the definition of thermodynamics is? Thermodynamics is a branch of science which deals with study of energy conversions between system and surrounding. Here fan is a system, anything outside of the fan is surrounding, room is a surrounding. Okay. So my dear students, now in the thermodynamics, always we will be dealing with only two types of energy. Keep in mind, one energy is heat, another energy is work. Always we will be dealing with these two types of work. So I can write the definition of thermodynamics in different way. What is that? Thermodynamics is a branch of science which deals with the study of energy conversion, that is between heat and work. It means heat can be converted into work or work can be converted into heat. In simple definition, what I can write is, so thermodynamics, ಇನ್ನೊಂದು definition ಇದು, one more definition, or ಅಂತ ಬರ್ಕೊಂಡು, thermodynamics is a branch of science which deals with the study of heat and work interaction. That also you can write. Branch of science which deals with study of heat and work interactions. This is also one more definition. Or else you can remember this is a general definition. Understood now? Understood now the definition of thermodynamics?
Yes, sir.
Any doubts in definition of thermodynamics?
No, sir.
Fine. Okay. Next. The next topic is, once after a definition of thermodynamics, we will be discussing that what is the second topic? Applications of thermodynamics. Okay, this will be asked for 5 marks. What is the question? Define thermodynamics and write a short note on applications of thermodynamics. So, being a mechanical engineer and aeronautical engineering, I will give the applications of thermodynamics as gas turbine power plant. Applications of thermodynamics. You can give any example. Okay, first we will understand applications of thermodynamics. First one, gas power plant. Okay, one more example you can write as steam power plant. Steam power plant, where we can see where energy conversions between work and heat. First, I will take gas power plant. So gas power plant consists of 3 major components, as we know. First component is compressor. Okay, dear students, gas power plant works on which cycle? Which thermodynamic cycle? Brayton cycle. Very good. So here it is. Compressor is a first component, and combustion chamber is a second component, and the third component is turbine. So as the name indicates, it is gas turbine. So I will call it as gas power plant is gas turbine. So gas turbine and compressor both are mounted on the same shaft. Both will be mounted on the same shaft. The reason behind this is simple. Here the gas turbine will be generating some 1000 joule of energy. For example, keep in mind it is giving 1000 joule of energy. And I told you, compressor is always work absorbing device. We have to supply mechanical work to the compressor. Instead of supplying external, so out of 1000 joule, I will pass some kind of mechanical energy. Maybe I will supply 200 joule of energy. So that I can save external energy. Okay, that is the meaning of. So 1 to 2 is a compression process, 2 to 3 is combustion, 3 to 4 is expansion process in the turbine. Dear students, now my question is, if I assume I am considering this compressor is a system, which part will be the surrounding, which components are the surrounding, you tell me. This is my system. I am going to study only compressor. Tell me.
The shaft between compressor and the turbine.
Yes, very good. This is one component, so it is surrounding. Is there any surroundings other than shaft? This is my system. Anything outside the system is surrounding. So here, this is also combustion chamber. This is also surrounding, no? This is outside of the system. Compressor is my system. So combustion chamber will be surrounding. Gas turbine will be surrounding. Correct? Okay. For example, your home is a system for you. Okay. You are sitting in your home. So for you, your home is a system. The neighboring home is a surrounding for you. Understood? So any space where you have chosen your study, the reason group of matter you have chosen for research work, start for study, that is as a compressor for a system. Okay. For example, you have selected gas turbine as your system, then combustion chamber, shaft, and this compressor will become surrounding. If you are considering combustion chamber as a system, then these two will become surrounding. Okay, one more example, my dear students, I will consider. Let us consider a cup of coffee. Okay, this is, assume it is a coffee cup. Here in the inside coffee is there. For me, coffee is a system. Now you tell me which one is surrounding.
The cup holder is the
The
surrounding.
cup holder is the surrounding. Or if cup of coffee is placed on a table. Now you tell me which one is the surrounding again. This is my system.
Yeah.
Yeah, table will be the surrounding.
Table also.
Correct. Just like, okay, this is not example of thermodynamics, but just for understanding, I told you, this is definition or understanding of thermodynamics. Okay. Here, now what is the definition of thermodynamics? Definition of thermodynamics is energy conversion between system and surrounding. Okay, that is the main, system and surrounding, or energy conversion between heat and work. Now we'll see where is that energy conversion are there in this example. Now, first in the compressor, what is the input energy? What is the output energy, my dear student?
For the compressor, input is air, sir.
Yeah, input working fluid is air. Okay, input working fluid is air. Correct, working fluid. Air is not a energy. Which is the energy you are supplied to the compressor? It may be mechanical energy or it may be heat energy. Out of two, which energy you are supplying to the compressor now? Here I am supplying
mechanical energy, sir.
Very good, very good. For compressor, I am input energy is mechanical energy. Very good. Now what the compressor is doing? Compressor function is what? Compressor absorb atmospheric air and increase the pressure, high pressure. So this mechanical energy is converted into high pressure energy. So output energy is high pressure energy. So one form of energy. So mechanical energy is one form. This mechanical energy is supplied to the compressor. Then the high pressure energy is coming outside. High pressure is nothing but high pressure air. Here it is low pressure air. Low pressure air enters inside the compressor and the compressor compresses the air. Then it will deliver high pressure. For example, it may 1 bar is the input pressure. You are getting here 10 bar. This is high pressure energy. Okay, dear students, now coming back to second component, combustion chamber. If you consider combustion chamber, what is the type of energy conversions are there? Here for the combustion chamber, I will be supplying fuel. Fuel may be diesel, petrol, coal, whatever may be. This in the combustion chamber, heat energy is liberated. Here air, high pressure air mix with fuel and you are getting heat energy. Understood? Heat energy is coming outside. Okay, this is one kind of energy conversions. Gas turbine. Here is high pressure and high temperature gas is enters inside the gas turbine. So turbine is always device which is used for converting. You will get mechanical energy. So what is the energy conversion, my dear students, in the gas turbine?
Mechanical to electrical, sir.
Yeah, mechanical to electrical is with the help of generator. Mechanical energy is input to the generator and output is electrical energy. That is you told for generator. I am asking you only for this turbine. Only for this turbine. Which is the energy? Which is the input energy for this turbine? Look at the input energy. This energy, high pressure, high temperature gas is energy. That is the energy input. Okay, I am not using, I am supplying gas. I am supplying high pressure, high temperature gas. So this is energy. Okay, energy stored in the gas. So this energy, when it hits the blades will rotate and the shaft will rotate. So heat energy, this is heat energy because it is high temperature. heat energy is converted into mechanical energy. That is one application of thermodynamics. Okay. Okay. Now one example ಹೇಳ್ತೀನಿ ನಿಮಗೆ ಸಿಂಪಲ್ ಆಗಿ. ಬೈಕ್ ತಗೊಳ್ಳಿ. ಓಕೆ, ಬೈಕ್ ಬೇಡ, ಬೈಸಿಕಲ್ ತಗೊಳ್ಳಿ. ಬೈಸಿಕಲ್ ಹಿಂಗ ಹಾಕೊಂಡು ಹಿಂಗ್ ತಗೊಳ್ಳಿ. ಬೈಸಿಕಲ್ ಅಂದ್ರೆ ಪ್ಯಾಡಲ್ ಇರುತ್ತೆ ನಮ್ಗೆ. ಓಕೆ, ಸೊ ಪ್ಯಾಡಲ್ ಈಸ್ ವಾಟ್ ಕೈಂಡ್ ಆಫ್ ಎನರ್ಜಿ? ಯು ಆರ್ ಪ್ಯಾಡಲಿಂಗ್ ಮಾಡ್ತಿದ್ರಲ್ಲ, ವಾಟ್ ಕೈಂಡ್ ಆಫ್ ಎನರ್ಜಿ ಇಟ್ ಈಸ್? Mechanical energy. You are supplying mechanical energy to the paddle. So what will happen once you supply mechanical energy to the paddle? Chain ಏನಾಗುತ್ತೆ? Chain will rotate. Yes, rotational energy you are getting, or kinetic energy you are getting. So this energy is converted into kinetic energy. Okay, so ಯಾವುದೇ example ತಗೊಳ್ಳಿ where there is a energy conversion ಆಗಿದ್ರೆ, that is called as thermodynamics. Okay, one simple example we will discuss, but do not write this example in the exam. Okay, in exam you explain gas power plant, steam power plant, etc. Okay, or you can also write petrol engine, diesel engine, because petrol engine is also there is kind of energy interaction. Now I will give one example, simple example. Assume this is kitchen room. In the kitchen room, I will take one stove. On stove, gas stove, single cylinder gas stove. This is burner. Okay, simple, only for understanding. Energy conversion agutte anta understand. Burner. On the burner, I am placing some vessel. On pathre burner. Okay, so to this vessel, I am putting one spoon. One spoon it component. Okay, running out of time. Okay, 10 minutes. So here, my dear students, this is LPG cylinder. It has some gases. What kind of energy it has stored in the LPG? LPG gas ಅಲ್ಲಿ ಯಾವ energy ಇದೆ? What kind of energy it is stored in the cylinder? Liquid energy. Working fluid is liquid energy. What mechanical energy or chemical energy or kinetic energy?
Chemical energy.
Very good, chemical energy. So this chemical energy, when it comes through burner and with the help of matchsticks, we are getting fire. So chemical energy is converted into which energy it is? If fire bandaga ಏನದು?
Kinetic energy.
Fire bandaga heat energy. Okay, it will be some velocity will be there, but we are neglecting that energy. So chemical energy is converted into heat energy. So this heat will transfer to the vessel, alwa, and you are assume you are taking some water. Olagade water ide. Okay, heat energy will be transferred to water first, correct or not? Through surface of vessel, correct or not? Okay.
Yes, sir.
After some time, this heat energy from the water will pass through this spoon. ಹೋಗುತ್ತಾ ಇಲ್ಲ? Spoon ಹೋಗುತ್ತಾ ಇಲ್ಲ ಹೇಳಿ? After some time.
Yes.
ಹೋಗುತ್ತೆ. So here same kind of energy is transfer. Assume ನೀವು ಬಂದು ಏನ್ ಮಾಡಿದಿರಾ, ಇದಕ್ಕೆ ಟಚ್ ಮಾಡಿದಿರಾ. Here at this place ಒಂದು ಸ್ವಲ್ಪ ಟಚ್ ಮಾಡ್ಬಿಟ್ಟಿದಿರಾ. Again, this spoon has high temperature. Okay, you cannot sustain so much of temperature. ಏನ್ ಮಾಡಿದಿರಾ, ಅದನ್ನ ಬಿಸಾಕ್ಬಿಟ್ಟಿದಿರಾ. ಬಿಸಾಕಿದಾಗ ಏನಾಯ್ತು, ಕೆಳಗಡೆ ಬಿದ್ದು ಬಿಡುತ್ತೆ ಸ್ಪೂನ್ ಕೆಳಗಡೆ ಬಿದ್ದಾಗ ಯಾವ ಎನರ್ಜಿ ಕನ್ವರ್ಷನ್ ಆಯ್ತು? ಹೀಟ್ ಎನರ್ಜಿ ಇಂದ ಬಂತು. ಹೀಟ್ ಎನರ್ಜಿ ಇಸ್ ಇನ್ಪುಟ್. ವೆನ್ ಹಿಟ್ಸ್ ದ ಗ್ರೌಂಡ್, ಏನ್ ಎನರ್ಜಿ ಬಂದಿರಬಹುದು ಹೇಳಿ? ದಿಸ್ ಹೀಟ್ ಎನರ್ಜಿ ಇಸ್ ಕನ್ವರ್ಟೆಡ್ ಇಂಟು ವಾಟ್? ಸ್ಪೂನ್ ಕೆಳಗಡೆ ಬಿದ್ದಾಗ ಏನ್ ಎನರ್ಜಿ ಬಂದಿರುತ್ತೆ?
Maybe kinetic energy, sir.
Kinetic energy. Okay, ಇಲ್ಲಿಂದ ಇಲ್ಲಿ ಬಿಡಬೇಕಾದ್ರೆ kinetic energy. Very good. But when hits the ground, ನೆಲದ ಮೇಲೆ ಬಿದ್ದಾಗ ಏನ್ ಬರುತ್ತೆ? ಒಂದು ಸ್ಪೂನ್ ನೆಲದ ಮೇಲೆ ಬಿತ್ತಂದ್ರೆ ಏನ್ ಬರುತ್ತೆ?
Sound energy. Very good. So this kinetic energy, when it hits the ground, it will be converted into sound energy. This sound energy again it will pass on the wall. Then it is micro level. We cannot sense through our eyes. So here
one form of energy is converted into another form. Kinetic energy, sorry, chemical energy is converted into heat energy. This heat energy is converted into kinetic energy. So kinetic energy, when it hits the ground, we are converting. We are not converting. That converts to sound energy. So here, one form of energy is converted into another form of energy. So this is thermodynamics. Understood? Have understood the definition of thermodynamics?
Yes, sir.
Okay. So example, if they ask applications of thermodynamics, we explain this Brayton cycle. Because anyway, you have understood the Brayton cycle, no? You explain in your own words. Okay, this is second topic, applications of thermodynamics. Then the third topic is macroscopic approach and microscopic approach. Okay, so this is the last topic of the class. Today we will discuss the difference between these two and we will wind up. This meeting may end now. After that, again, you join with the same link. Okay, so if it is disconnected in between, if you join with the same link. Now, my dear students, I will make two columns. One side I will write macroscopic approach. Another side I will write microscopic approach. Very easy to understand. Okay. Microscopic approach, thermodynamics. Okay, in the interview, they may ask you what type of thermodynamics you have studied in the third semester of your engineering course, whether microscopic thermodynamics you have studied or macroscopic thermodynamics you have studied. They may ask you. Okay, this is the solution. What is the solution? First point. Okay, to understand first microscopic, let us consider a piston and it is a cylinder. Assume it is petrol engine. Okay, simple example, petrol engine. Here, there are number of gases. For example, this is molecule 1. Here is a molecule 2, molecule 3, molecule 4, 5, 6, 7, 8, 9. So, n number of molecules. We don't know n number because that is a chamber, 1 metric cube is a volume. So, there will be n number of molecules. Okay. In the microscopic approach, what is microscopic approach is? Microscopic approach of thermodynamics deals with study of properties of individual molecules. I'm using the word properties. What properties? Pressure, volume, temperature. Measure. These three are the measure. In the microscopic approach, being an engineering student, you are going to determine pressure of molecule 1. How much is the pressure of only molecule 1, not molecule 2 later, P1. And you are going to identify molecule 1 volume. And you are going to measure the temperature of molecule. Okay. Similarly, some students, one more student is doing P2, V2, and T2 is the pressure, volume, and temperature of the molecule 2. Understood? So, what is microscopic approach is? Microscopic approach of thermodynamics deals with the study of properties like pressure, volume, and temperature of individual gas molecules. Individual gas molecules. That is microscopic approach. But in the macroscopic, as the name indicates, it is macro. And here also some gases will be there. Here, n number of molecules are there. In the macroscopic approach, we are not dealing with or we are not studying the properties like pressure, volume, temperature of individual gas molecule. Instead of individual, we'll be dealing with pressure of mixture is P. How much is the pressure of the mixture? Not only individual molecules, mixture means outside surface. And what is the volume of this mixture? And temperature of this mixture. That is macroscopic approach. I hope you understand what is macroscopic and microscopic. In the macroscopic thermodynamics, okay, we are dealing with or we are studying the properties of gas mixtures. gas mixtures. Okay, not individual molecules, but here we are dealing with individual gas molecules. That is first point of macroscopic and micro. Dear students, now with common sense, you tell me which type of thermodynamics is very difficult to analyze. Out of these two, which one is difficult? You say me whether macro is different or micro is different. Which one is difficult for you? If I given a task, which one is difficult
macro,
for you? Micro or macro?
Macroscopic.
MI or
Macroscopic.
So yes.
MA, sir.
This will be very easy because you are using one thermometer and putting here to measure the thermodynamic temperature of this mixture. This will be very easy. Okay. For example, you have taken on thermometer and you have inserted in the gas mixture and you can make a temperature. But here, if I ask you to measure the molecule 4 temperature, what we need to do? We have to take the thermometer and exactly where is the molecule 4 you have to find out, and you have to find the temperature of that 4th molecule. It is very difficult now. So microscopic is very difficult. Microscopic is very difficult to analyze. Macroscopic is easy to analyze, easy to conduct some experiments in the laboratory. So out of these two, in your course, you are studying macroscopic thermodynamics. So study of macroscopic approach thermodynamics is also called as, keep in mind, it is classical thermodynamics. So which thermodynamics you are studying? If somebody asks you which thermodynamic you are studying, you should say classical thermodynamics. They may ask you what is the approach, microscopic approach of thermodynamics, that is